Welcome to today's notes on section 9.4, the Pythagorean Theorem, which is probably the most important theorem that you're going to learn about in geometry. So if you walk away with anything from this class, this is it. So our goals today are to use the Pythagorean Theorem to solve for missing side lengths of a right triangle. So we'll have two, we're trying to find the third. And we're going to determine if a triangle is acute, right, or obtuse based only on side measurements, knowing nothing about angles. So the Pythagorean theorem says the square of the measure of the hypotenuse of a right triangle, notice that's underlined there, it's really important you have a right triangle, is used to measure, is equal to the sum of the squares of the measures of the legs. So if we take a squared plus b squared, a and b are the legs, those added up have to equal c squared, and c is the hypotenuse. So as an example, we have two sides right here. Side A is 8 and side B is 15, and we're going to call this side X C because it's across from a right angle. That's our hypotenuse. So according to the Pythagorean theorem, I'm supposed to take a squared plus b squared, and it should equal c squared. 8 squared is 64, 15 squared is 225. If I set that equal to c squared, then I can solve. So I'm going to add these guys up. 64 and 225 is 289. And then solve for c by taking the square root. Turns out that 289 is a perfect square, which is awesome, because when you simplify that down, you're going to end up getting 17. If it's not a perfect square, that's when you have to simplify the radical. So you might have something like square root of 32, which you're going to have to break down to 16 and 2, giving you 4 root 2. Simplified radicals are the way you want to always approach these problems. You'll notice on these segments we have a side of 8, 15, and 17. All of those sides are whole numbers. This is what's called a Pythagorean triple, where all three sides of a triangle are integers, they're whole numbers. That's something we'll learn about later. Our second goal is to figure out if the triangles are right, acute, or obtuse just based on knowing the sides. So if a squared plus b squared is equal to c squared, then we have a right triangle, and that's just using the Pythagorean theorem. If a squared plus b squared is greater than c squared, we have an acute triangle. And it seems kind of counterintuitive. You would think that if these guys are bigger than the third side, then we would have an obtuse triangle. It's greater than. Well, we really want to start thinking about that third side and how it compares. If a squared and b squared are bigger than c squared, that means that c is actually smaller than we expected it to be to make a right triangle. So what would end up happening is that right angle is going to start to collapse in on itself, and it's going to create an angle smaller than 90 degrees, or an acute angle. So we already know the other two angles had to be acute. The third one must be as well. Similarly, if a squared plus b squared is less than c squared, that means that c is bigger than we expected it to be. It has stretched out that right angle so that it's bigger than 90 degrees. An angle bigger than 90 degrees is obtuse. So use the smaller sides a and b, and the biggest side is c. Now again, we don't know for sure it's a right triangle until we go through and find out. So example number 2, we're going to classify the triangle with sides 3, 8, and 10 as acute, right, or obtuse. So my biggest side is 10. I'm going to label that as my C side. And that means that A is 3 and B is 8. Now it really doesn't matter if you mix these up. If you say A is 3 is B and then 8 is A, it doesn't make a difference there. C is the biggest side though. We have to do that one. So we're going to do 3 squared plus 8 squared, and we're going to compare it to 10 squared. 3 squared is 9, 8 squared is 64, and 10 squared is 100. So if I add these up, 9 and 64 is going to give me 73, and that's going to be 100. I know that 73 is going to be less than 100. The C side is much bigger than we expected it to be, which means it's going to stretch that right triangle out into an obtuse triangle. If we had 73 was greater than, let's say, 50, then we would say it's an acute triangle because the third side, the biggest side, is smaller than we anticipated it would be. And that's it for the notes. Again, our goals were to make sure that we know how to use the Pythagorean theorem to solve a problem, and also that we are able to classify a triangle based on only the side measurement.